All right, Michael, you're next. Tell us more about KeyShot scripting.
Hello, everybody. So I've got a quick lightning demo here today that I think I can do in just a few minutes. So I'm a Python developer, and mostly I do work with clients to build and maintain computational infrastructure. So I build big computational clusters and that sort of thing for people and big clients to run data science projects in machine learning. So my day-to-day job is really quite a bit different than what I'm about to show you here. So I have a hobby, which is something I've enjoyed for 20 years ever since I was in high school, which is computer-aided design, drafting, three-dimensional modeling and rendering, that sort of thing. So I'm going to give you a demonstration of some stuff I'm doing as a hobbyist. I'm still learning this, so I'm not very good. I just wanted to give you that preamble. So let me show you what we got. All right, so this is a modeling program. It's somewhat realistic rendering, generally categorized as photorealistic, although it's a little bit more of it's got a little bit of a obvious CGI effect to it, so that it can render quickly. So if you have experience with CAD and rendering systems, you would be familiar with these sorts of things. They're GUI driven, lots of buttons, takes a long time to master. And as you can see, I put a material on the cube that makes it a mirror, and it can reflect the sphere. So a pretty simple layout of two objects that can be manipulated in three-dimensional space. I can zoom in here and show you the reflections. As it rotates around, you'll notice that it fuzzes out. That's not a bug. That's a computational trick to accelerate the animation. So when you render the three-dimensional geometry, it actually randomly makes some of the pixels black, so that the GPU doesn't have to compute the necessary colorization of those pixels. And then as you move around, it will understand the precise geometry that you're looking at, and then make the black pixels go away as it grinds through the computational wavefront to colorize the pixels accordingly. So what's this have to do with Python? Okay, so most of the time a user with a tool set like this uses the graphical user environment. But what if you want to do something like this? Say, for example, that I want to make it be the case that I catalog a selection of views where the angle that the camera looks at the model set. So what I can do is, with a traditional workflow, you would add a camera, and then I could zoom, make a different angle, go over here, right click, make a different representation. Let's look at it from the bottom, that sort of thing. Oops. And then a right click on camera, add a camera. So now I've got all these named views. And when I click from one to the other, it should snap right back to the exact coordinates set of the particular camera. Now this is very valuable, but I kind of did that manually, so it wasn't geometrically precise. What if I want to do this 100 times with 100 different model sets where I always have the same exact camera angles? Well, this tool has integrated Python. So here in the Python technology, you can see there's a couple, well, 3 relatively simple Python scripts that I've demonstrated work well, and I think you'll like them. And this is running in Python 3.8. So let me restart this and do that again programmatically. So you open up a model set in a very traditional way. I mean, you could have Python open up the model set as well, because the Python is, anything you can do with the graphical user interface, you can do with Python. So now we have a base model and no camera views other than the default camera. So I can pull up a script and create standard views, select that, double click it, and I run it. Now it's done. And that it runs real quick. And as you can see, it populated the cameras with names and where they have a particular precise geometric orientation. And this, again, so it's not random, there's no human error in the precision of these coordinates. It's literally a bottom view. It's quite precise. So let me show you what the script looks like. It's basically Python. So they're very small scripts. You don't need to import very much. And in fact, in this one, you don't import anything. It's kind of weird because they're running some sort of macro. I don't fully understand exactly what they're doing. It's not exactly pure Python. It's a very slightly modified dialect, or not even necessarily a dialect, but it's got some sort of macro intermediate step. And what's going on is there's this Lux module or object that sort of just exists. It's not imported from any library. It's just there. That doesn't exist in the Python standard library. It's added in by the KeyShot rendering tool. So they're doing something to take the Python file, pre-scan it, and sort of inject their own Python library code to add in user functionality. And I can understand why they did that, but it's not traditional Python. It's not Pythonic, but it works. And then from there on out, you just write Python. So what's going on here is you produce a dictionary in very traditional way, where you call into existence a particular view, and then you can name them for whatever and however you would like to name them. Then you loop through them. So for view and views, you pull up one of the views that you've created, and you check whether or not it's been created, and then you set the camera.
Michael, can you show us the actual script? Because I'm seeing the screen. Maybe it's only me, but maybe you're showing it in a different window.
No, yes, that's what happened. Hold on a second. Sorry about that. Can you see these scripts?
Now we see the script. Now go back to what you were trying to explain.
Okay, I apologize for that. So yeah, so I'm trying to explain that it's a simple script, very straightforward, almost pure Python. So you set a dictionary with your views. You can name them whatever you want here, and then you loop through the views for view and views. Then you set the camera to the value of the object attribute that defines the definition of a top view, for example. And then once you update the camera set, then you save the camera with an object call that will, and this part here makes all of the views pop in over here. So I can imagine that this would be quite powerful. I've still got a substantial amount to learn, but let me show you another fun script. Say, for example, that I want more cubes. If you were to do this manually, you could select the cube, duplicate the part, and now you have more cubes. And you could do this a large number of times, and then you can move the cubes around, rearrange them. I could change the material color. But if you wanted to do that programmatically, you can run a script. So here's a random scattering script, which is interesting. And this one's more sophisticated because it pops up a little graphical user tool to take input from the operator.
Okay, show us the script.
Right.
Here we go.
See. So this takes a little bit more Python. We're actually going to import OS and use the random number generator functionality from Python. We're making two little functions that are just nice little utility functions that KeyShot needs to do the rest of the computation. And this is using the style that has a main entry point. So at the bottom of this script, it calls main, the main function is called, which jumps up to here and then begins the bulk of the computation. So we're already getting a little bit more sophisticated. The way they like to program reminds me of sort of a little bit like C, but it works. So what this is doing is it's actually searching the objects in the KeyShot scene to find the geometric objects that exist in real, and then once it's found some of them, it tells you which of those objects it has identified in this input dialog. So it found a sphere and a cube, which makes sense because that's exactly what's in the screen. And it tells you based on this that it's pre-selecting the first object, the first geometric object that it's identified. So when you change the options on this input dialog, you're effectively changing the variables that are going to end up in this ops object. And once this object is in the Python interpreter, now here it's just traditional Python. So 400 is a little bit large. Let's go to 4. But what this is going to do is we're going to do operations on the cube. We're going to duplicate it 4 times here for duplication. The number of duplications that are being made is duplicated on the duplication count is done on line 48. And then it's going to loop through each of the duplicated objects and modify their X, Y, and Z coordinates here to move them around in 3-dimensional space. So when you press OK, you're going to get some random arrangement of cubes that sort of just float around in space. Now, as you might imagine, every time I do this, the cubes will be in a different position relative to each other, unless, of course, I set the random number seed, which would allow me to reproduce the work in any particular way. So now this is already much more complicated than the first demonstration I showed you. So with this technology, I can duplicate hundreds and hundreds of objects. I can arrange them however I want. I could make a precise, I could put them on a logarithmic relationship to each other, which would be extremely difficult to do manually. So I could separate them 3-dimensionally based on the Fibonacci pattern, for example. I can do anything I want, which would be very, very difficult to do unless you did it programmatically. As you can see, the computer's already actually acting a little bit more slow because it's dropping more pixels as it does a quick rotate, because the ray trace path is a lot more complicated as all of these mirrored surfaces bounce off of each other. I have one more quick demonstration of what you can do with the script. So let me discard that file. And now I'm going to show you third script, which is going to renders images. Now, this is, again, using the same graphical user interface input technology to run this utility file. And this file is actually, what it's doing is it's using standard Python to find all of the files in a particular folder. And when it's gathered up the list of files in the folder that's selected here, then it will prune them based on the file format, the file extension, to verify that it's using a KeyShot file in this particular case. Once it's found the files, it's going to sequentially render each one of them to a PNG output and as a batch. And not only it's going to add all of the model files that it finds in the folder in question it's going to add them to the queue, and then it's going to process the queue specifically. Now, if I didn't have this check mark here and I just have it empty, then all of the model sets will be added to the queue, but they won't actually be rendered. And this graphical check mark is implemented in Python here. So if you have this enabled, then that makes this variable true, and then it does a LUX call to process the rendering queue. So if this was working well last night, so let's run it again and see what happens. So this should render 3 object scenes. Okay, now so it loads one, then loads the second, then loads the third. Good. Now the rendering engine should have popped up. Here we go. Good. So you can see the independent rendering process here. It'll take about a minute or 2 per scene. It's using an algorithm that samples the 3D geometry about 250 times or so to refine the quality of the image. Okay, now good. So that's the second one coming out online. So I could have 1,000, 10,000 images, something like this, and I could procedurally generate all of them, let it run all night, and then when I wake up in the morning, I'd have a folder just populated with a wide variety of images with different colors, different textures, images observed from different angles with different shadow effects, etc. This third one is going to take a little bit longer because this is glass. So the rendering process has to render a ray trace going right through the glass. And then it has all time internal caustics and internal reflections and shadows. But it's a relatively small model and an okay computer, so it won't be too bad. So when this is done, the entire Python script should exit and then back with successful. Cool. So now those images should exist in demos. Good. Right. Good. And there's an image. That's pretty much all I had to show you today. I'm excited by the capability of being able to do supposedly anything that I can imagine I can do in Python.
Like a open source type of project, or is it just on Windows, or?
It's not open source, unfortunately. You can run it on Windows and Mac.
Right. Yeah. Yeah. Go ahead.
I'm seeing this sort of thing a lot. People, open source and commercial products are starting. It's becoming increasingly common for commercial products to integrate Python. I've seen it in a wide variety of CAD programs, audio manipulation programs, just all kinds of workflows where there's, if there's something that you would want to automate, people seem to be adopting Python as the internal toolkit that they're providing in the products that they produce.
Yeah, I mean, I've been looking for a way to make like a music video using like some kind of 3D shapes where maybe I use the amplitude of the sound, and then maybe imagine those cubes that you show, like maybe have those cubes like pulsate with the music. It's kind of, I mean, it's really nice that you can use Python to automate some of that stuff, a language that I know. Yeah, I'll take a look at KeyShot, see if I can afford it, but it'll be kind of nice to be able to use Python to create something, some kind of art, some kind of visual art using like having music and some 3D animation.
Yeah, I'm pretty sure that the Python will allow me to animate things as well. I haven't gotten that far yet.
Yeah, it's like still maybe like use the amplitude, like maybe put my song in there, and then I'm pretty sure there's libraries in Python that can analyze the sound, and then maybe just read the amplitude value, and then based on the amplitude value, let's say you have like a bunch of cubes, so you start from the middle of the set, and then maybe have them pulsate or do some random stuff. That would be pretty cool.
Sure, you can do that.
Nice.
Can you import libraries other than like, how do you set up the environment of the libraries where it sits?
That's a great question. So the KeyShot package ships with, they deploy a side deployment of Python 3.8. I have not verified this because I haven't actually done it personally, but my understanding is that you can log into, you can track down the actual Python interpreter. And when you run the Python interpreter in the right way, you will be able to install packages. It's limited. Sorry. I'm not sure that it uses pip in the way that you would expect. Again, this is a recurring theme in commercial software. While it's true that people are beginning to adopt Python as sort of like the tool of choice, where a few years ago people were writing their own domain-specific languages, and that people would be all, and the migration seems to be to adopt Python. My opinion is that they haven't adopted full Python with all of the trimmings and all of the ecosystem components. They have a tendency, commercial integrators that produce a product that integrates with Python, they have a tendency to kind of just give you Python stock, and you're kind of stuck to the standard library. You can often fight it to add in more things, but that gets really advanced. So that's one of the things I'm going to do soon, is I'm going to try to add in an additional module and see what happens. But even having standard Python just locked into the standard library is quite a bit better than what we used to have even a few years ago.
Oh yeah, I agree. It's like Visual Basic but now it's like in all sorts of applications they used before. So Python in many ways is replicating what Visual Basic did like 20 something years ago to Microsoft. They used to have all those like they used to have like Word, Excel, all of those were embedded and were driven by Visual Basic variants. So now it's happening with Python, but it's much more widespread. It's not the first application that I saw that works like this. And this is great.
Yeah, I agree with you. I think that the relationship between the history of Basic, I think that's right. Yeah.
So KeyShot, like, make me understand, so it's more like a CAD, right? Or Fusion 360, or where you can create your own objects, things like that.
KeyShot's KeyShot's standalone rendering software. So it doesn't make the geometry. You have to make the geometry in a separate program, and then you import your geometry into KeyShot for colorization and camera shots.
I got it.
But it's pretty good from that perspective. If you show, for example, show us the screen again. This is something that's like 20 years ago you couldn't see in applications. In real time, it renders the mirror. It's like the ability to render those things, like have the mirror thing that you were showing, like a mirror surface, is not that trivial, because you used to have like be able to do it only with ray tracing. What you see now, that the ball reflects in this, it's not trivial.
No, it's definitely not.
And it does this near real time. I don't know how. I'm curious how they did it. Like what kind of trick they used, because it's not doing ray tracing.
It is. It's doing a variant of ray tracing, but it's doing
it in real time.
Yes.
Oh my God! Real time ray tracing.
Yeah, we can do that now.
This was not even imaginable 20 years ago. It's like your computer is now warm and the GPU is running.
Yes. Oh yes. The GPU is actually pretty hot.
Uh-huh.
But it's running a lot of the core technology. It's borrowing from the core technology of like a video game engine, but yes, it's using real-time ray tracing. It's not exactly photorealistic. It's still, they're doing tricks to accelerate the computation at the cost of realism. So if you look at it, you would know it was made with CGI. It's in their business, their choice was, it's fine for a consumer to notice that it's obviously CGI, as long as it's a reasonable and attractive, sufficiently realistic representation of what we're trying to visualize. It's not, this product is not designed to give photorealistic renderings that are so perfect that at a glance, an average person wouldn't even know the difference.
No, but
if you have something like that, those things are still, they're harder to use and they're slower to render.
Yes, to get profit, but reflections is something that even in video games it's hard to do. And they really, think about the video. Shadows is easier. Reflections is kind of harder.
Oh yes.
In shadows, you have the real. You can trace because you know where it is. The reflections are kind of harder.
Hey, Michael, quick question. Do you think we can do something like this can be used for anomaly detection of the object?
Yes. Yes, you can do that. So what I'm gonna, not only, I'm trying, Jacob's right, but I'm trying to make a scene that's difficult for this to render. So you got the real-time reflection, which is done against the GPU. Let me put in some glass here. Okay, so now we should be able to see through the glass into the reflected mirror and have the mirror, and yeah, that's pretty, yeah, good. So the glass, there's a lot of geometry being computed right there. The rays are bouncing all over the place. They're reflecting off of each other, being bent. They're being bent through refraction calculations as they go through the glass.
Yes.
Wow, that's amazing.
This is difficult and it's done in real time. This is like 20 years ago. No, it's like, this is like a computer farm working on this.
Oh yeah.
Oh my God, how things have moved fast. Yeah, and it's with Python, which is great.
So if you put in too many objects,
Ooh, that's
it'll just keep, it'll try, it's not, this is not an error. Like it's actually, doing what it's doing the correct geometry. It's
Oh, man.
just hundreds of bounce rounds. So I randomly put in 40 cubes, and that's why they're inside of each other and everything. But as you can see, there's, with this much geometry, the optimized algorithms are bouncing rays up and down and over and reflecting off of objects, and then triple, you know, fourth derivative reflection calculations. Yeah. No, it's amazing. And I look forward to see what artists can do with technology like this combined with Python. So I'm just a hobbyist, just playing around. But I really, yeah, when in a few years, when professionals get the power of Python, it's going to be very interesting.
Well, they already have. In the evening of Python coding, we show another 3D animation that already uses Python. It's like, it seems that more and more things are using Python, and as like a scripting language attached to this. I know GIS and others have, it's becoming more and more prevalent. We'll be in an automated world soon.
Yeah.
Yeah.
Just a piece of glass. Cool. Well, thanks for your time, everybody. I can end my presentation.
Okay.
Well, thank you so much. This was a lot of fun. Thank you.
Thank you. Cool.
Awesome.
Thanks, everybody.
Right, I'll stop the recording right now, and then all right, stop.